Okay, so let's get into some examples. So if you can see here, we've got our traditional least common multiple of two numbers, and then we have its extension into our algebra field of study. So we're talking about numbers and then expressions. Remember, algebraic expressions involve numbers and letters and operations here. So operation being the multiplication going on in between these pieces, in between those factors. Okay, so we're going to start with number 1. And again, we want to prime factorization both of these. I like to do factor trees. That's just my preferred method. All right, so 48, just the two factors that come off the top of my head are 4 and 12, and that's what we want. Now remember, we keep factoring these larger factors until we get prime factors. So prime factors are numbers whose only divisors are 1 in itself. Well, 4 is 2 times 2, and I actually like to kind of circle any primes I see because that tells me that I can stop branching there. And then 12 is 4 times 3, and 3 is a prime, but 4 is not, so I need to factor it further. And so that is 2 times 2, and there's our primes. So our most well-known primes are 2, 3, 5, 7, 11, 13, 17, 19, and after that, there are more primes that exist, but those are the ones that are going to be most common. Okay, so 48, I'm going to come up here and record it. 48 is equal to 1, 2, 3, 4, 2, 4, or 4 2's, I should say, multiplied together, and 1, 3. So you just want to take those ends and record them. And then I also need to do my prime factor tree for 54, so I'm just going to kind of come over and do that to the side. The first ones that pop up to me are 6 and 9, pretty close. So here's 2 and 3, and those are prime, so I'm going to circle them so I know to stop. And then 9 is also 3 times 3, and those are both prime, so I'm going to stop. Okay, so I'm going to come record underneath that 54 is 1, 2, and 3 3's. If you ever are concerned, do I have the prime factorization correct? Just, type that into your calculator and make sure it returns the appropriate value. So 2 times 3 times 3 times 3 is definitely going to be 54. Okay, so I have my prime factorization. So that was the first step. And then the second step says we need to list each factor that we see occurring. Okay, so in 48, I see a factor of 2. So here's our factors. And then I also see a factor of 3. And then in 54, I see a factor of 2. And then I also see a factor of 3. So I don't have to write them down again because, again, we don't want those repeats. And then I also need to now record the max number of factors that we saw in any one prime factorization. Okay, so we're looking at this factor of 2. In 48, it occurred 4 times, and in 54, it occurred 1 time. So the max number of times it occurred was 4. And then if we look at the factor of 3, there's 1 3 here, but it occurred 3 times in the prime factorization of 3, so I'm going to write down the largest of those happenings, 3 times. So my LCM then, I'm going to take each factor that I observed in the prime factorization of either of those numbers. So it doesn't have to be a common factor. In this case, they just have common factors. But you are going to list any factors that you see in those prime factorizations, and then you're going to take that factor and multiply it the greatest number of times that you see it occurring in the factored form of that number. So I need 4 2's. So I need to be multiplying 2 4 times, and then I need to be multiplying 3 3 times. And so the LCM then is equal to, we throw that into our calculator, I believe that is 432. So what we're saying with that is the smallest multiple that these two numbers have in common. So if we were to list out the multiples of 48 and the multiples of 54, the first one they would have in common is 432. So instead of having to list all of those multiples out, once you get the hang of this actually goes pretty quickly. Okay, so now we're going to stop this video and then we'll come back to the next.